Hello, my name is Cristancho, and this is my user story video for user story 2581 proximity search. Alright, so before I discuss the user story, the purpose of this video is pretty quick. I'm going to discuss the user story. I'm going to show the diagrams. I'm just pretty much in a nutshell, the goal of this video is to show you the whole process from starting from scratch, which is basically the user story, all the way to implementation of the user story. And I'm going to show you what I learned along the way. So now to the first step, user story. The ID is 2581. It features proximity search. And here's a description. As a home buyer or renter, I would like to search for properties near a location I like so that I can browse for properties in proximity to that location. In a nutshell, I want to be able to search for properties in a location I care about. And that's pretty much it. A quick example. I want to search for properties in Miami, so I only want properties from Miami. And yeah, that's my user story. The acceptance criteria. You could get the location information from a query given. What this means is that you could get the latitude and longitude from any kind of query. So let's say Miami, you get the coordinates from Miami, the latitude and longitude of Miami. Second thing, can't use location information to find properties nearby using the proximity algorithm. In a nutshell, this means using the latitude and longitude I got from the previous step and use that to search through all the properties in BreazeHome to find properties nearby. So if I'm searching for Miami and I get the latitude and longitude of Miami, I want to search through all the properties of BreazeHome, all the latitude and longitude of those properties, and find the ones that are nearby. Also, I wanted to have a UI familiar to the user. Simply much, put it simply. I don't want a complicated UI. I want a UI that is familiar to the user so they don't have to learn to use the product. So a good starting point is familiar like Google, just one query box, one search box. I also want the results map to realign to display the proximity properties. I want the users to get feedback that they actually got properties near a location they care about. So in the results map, I want it to change to the proximity. If you're searching for Miami, I want the map to display Miami. So here's the use case diagram. The buyer will enter into the input form. The input form will get a property search. The search engine will talk to Google to get the coordinates. The search engine will then perform a proximity search with the coordinates. Then it goes back and returns the properties nearby, and then it displays those results. Here's the class diagram. There's only 2 classes in my implementation, but a lot of functions. I like small classes. So the search engine, the attributes, or the class data is going to be a query, which is a string, and a query set, which is basically all the properties in BreazeHome. The to function is init to initialize the class, and start to start the search engine, which is all the logic to starting a search engine. The maps API, which is what search engine depends on, is simply has the attribute API key, which is the key to access the API, and the get coordinate function, which is, put it simply, it's just the URL string that tells the API, please get me the coordinates from a query. Sequence diagram. I'm going to discuss the sequence as follows. The front end searches for the query. The backend then talks to Google and says, can you please translate this query to coordinates? Google then returns the coordinates. The backend then returns properties that are nearby those coordinates. So let's talk about a use case. Imagine you're an out-of-state FIU student, and your goal is to find a property near FIU, but there's a problem. You're out of state and you don't know the addresses around FIU. You don't know 17th Street, you don't know 117, you don't know nothing. All you know is FIU. We don't expect them to enter the whole entire address, you just want them to enter FIU. So that's the use case. So I'm going to show you a demo of that use case. But before then, I want to discuss how am I going to demo this so people don't get confused. First off, I'm going to show the whole entire use case, which is simply typing FIU, pressing enter, and then showing the results from FIU. But I want to show the user the implementation side by side to the demo. On the left would be the final product, and on the right would be the implementation in code, and I'll discuss it back and forth. So without further ado, let's begin. So let's enter the password, the magic password. Okay, so here is the landing page which every user will see when they go to BreazeHome.com. Alright, And so this is the landing page, and on the right is landing.html. I'm not going to really discuss the file names or where they're located, because I already pretty much put all the files that I've modified in the maintenance video, and I really recommend that if you want to start modifying my code, the maintenance video is a great place to start modifying my code. So all I'm going to do is pretty much show you the flow based on that use case of typing FIU and pressing enter, and then on the right the implementation of that. Alright, hopefully it's not that confusing. Florida International University. You could type that, but it's pretty long. This is a student. Students don't really type the whole entire thing. So they type in FIU. Now, before I press enter, I want to show you what's going on. So here is the HTML right here. The underline is where I'm currently want you to focus on. So this is pretty much an HTML element that collects the input. So you see FIU? This HTML element collects the input and puts it in something called search text. So let's keep moving on, and what else it does. That's the placeholder right here, which shows the user. Here's the autocomplete functionality, which I showed you before. And here is the, I wish I knew the name of it, but in a nutshell, this is just the event. In case you press enter, it calls the function right here, address search, in the controller, which I'm going to show next. But before that, let's press enter. So in a nutshell, landing.html pretty much collects the input from the landing page. So it will collect the string FIU. So let's press enter. Takes a bit because proximity search is a little slow, which I put in the shortcomings. Alright, so we got FIU, and I'm going to zoom in so I'm not trying to trick you guys. If you recognize this, that's FIU right there, and there is Sweetwater. So for those of you who go to FIU, which is I hope everyone that watches this video, there you go. It's to prove to you that proximity search works. Okay, so what happened here? You know, it looks like it's just one page to another, but there's a lot of logic to get to that one page. If you want, you could skip this part because I'm going to discuss a lot of things, but if you really want to see the implementation and how it works, and yeah, so stay put if you want to see the implementation, or skip forward if you want to pretty much see what I've learned during this user story. So let's begin. So what happens? We collect the input. Remember when I said the landing.html just collects the input? So it gets the FIU string. So now let's go to the controllers. So it'll be landing.js. Controllers are pretty much functions that are connected to the view, which is landing.html. So right here is my autocomplete code, which I'm not going to discuss too much. And right here is the meat of it all, which is the address search. If you had a keen eye in the HTML element in the landing, this is where you send the text. So right here, if you had an autocomplete, here's the autocomplete text. And here's the search text I was talking about earlier. If this is from the input box, so it gets FIU and puts it into that variable right there. This line right here says if the query is white space, don't continue. But if it's not white space and it's a legit query, please continue. So right here is the most important line in the function. It calls the service to search addresses. It pretty much calls the service to connect to the backend. This is the meat of the whole entire implementation. So let's go to the service. So we go to services, we go to properties, and here is the search address. This is the meat. So what this does is that it gives out a request. It asks the backend, can you please perform a proximity search using right here, address equals what I typed, which is FIU. So let's go to the backend to see how the backend processes that request. Let's make sure that we're here. We are. So here is where the request gets sent, right here. So the first line is we get the query set. So what's a query set? The query set is the set of all the properties that BreazeHome has. And right here, this line, it gets the request that we got from the front end, and it tells it, can you please get me the address, the query, which was FIU. So it places FIU into this variable right here. This line says if there's a query, which is the FIU string, initialize the search engine, which takes the query in the query set. And remember, the query set's the list of all the properties. And then run the search engine, and then return the filtered query set. So let's see the search engine, which is in search.py. This whole file is my implementation. Like I said, the init initializes the search engine. Here's start, which is control. It contains all the logic to running the search engine. And before it was complex, but now it's pretty simple. It basically says if it's a query, which means if it's a valid query, run the proximity search. If it's an invalid query, return an empty query set. Sounds pretty reasonable. If you requested something and I don't like that you requested, I want you to return nothing. If you requested something that exists, I'm going to give you what you want. So search proximity is the proximity search algorithm. So let's go to search proximity, which is right here. Now, to keep the video short, I'm not going to really discuss the implementation of my API manager. All you need to understand is that the API manager is just simply a class that has an API key as its attribute. That's all it is. And then it uses that API key to talk to the API. In this case, here we get the API key. Here we initialize the API manager, which is the maps API manager. And this line is what translates the query, which was FIU, to the coordinates. And then we put it in destination. So destination is pretty much the latitude and longitude. So keep that in mind. Destination is what we want. The destination is FIU. If something goes wrong, we return a query set that's empty. So here we go next. This is the proximity algorithm. The first thing we do is we get the query set, which is the set of all the properties in BreazeHome, and we run an SQL query saying we only want the ID and we only want the location point. I'm conflicted whether I should discuss those, but I don't think I should. Just know that I want the ID and the location point of all the properties. And this is the proximity algorithm right here. What this says right here is, for every tuple, which was right here, the ID and location point, if the destination is in proximity to the property, return that. And then we use that right here, and we filter out the query set in here. Now, in my maintenance video, I discussed that this line right here that I just underlined is where the slowdown comes from, because to keep the speed, you have to keep everything a query set. And right here, this is when I open the query set, and this is where the penalty happens. So if I were you, focus on this. This is in my maintenance video. And right here, this filters out the properties. It returns all the nearby properties. So I know I have to breathe, and you have to think. A lot of things just that I discussed. In a nutshell, the search engine gets a query and returns all the properties nearby from that query. So let's go back to the front end. And if we remember, it's services and property. So here is the then, which means if it's a successful call, return the response from the backend. And the response is pretty much all the properties that were filtered out, all the nearby properties. So let's go to the controllers again, and let's go to the function I said was so important, which is address search. So here's where we left off, which is the most important line. And after we did our whole entire tour of the backend, we get all the properties that we need. So after we get the properties that we need, we run this. We basically set all the scope properties, the root scope properties, to the nearby properties. We set the address flag, and then we go to the results page. So we move from the landing to this page right here that we currently went to, which is the results page. So let's go to the results page view. Sorry about that. I don't want to insert right now. For sure, I don't want to insert any text. So here's the next step. All this pretty much says is this. There's a bunch of logic further down. I'm not going to show it, which goes through all the properties that we just set, and it displays them over here. So it iterates through all the nearby properties that we return from the backend, and it displays it right there. So what this line does is the refinement search, and all refinement search is it's just a search engine in the results page. So it does the same exact functionality. If we press FAU, let's say we want to be a Florida Atlantic University student, it will search for FAU, which is right now, bam, right there. If you're from FAU, you know it's in Boca Raton, so you know right there is all the properties from FAU. So that's pretty much refinement search. It's just a search inside the results page. So finally we reach the end, and there's only one last thing to discuss, is how does the map change. So let's go to how the map changes. Maps is a controller. So let's go to results.js. So set up results map. This sets up the results map from the beginning. So before, the map is not set up, so this function sets up the map. So that's pretty much all it does. It just says set up the map and then move the map to the first property in the proximity search, which is right there. The next thing is, here's the refinement search, and this is what we just did when we searched for FAU. And this line right here, it moves the current map. So after the map is initialized, we just want to call the function saying, can you please move to the position of the first property in the proximity map? And if you stayed with me this long, that's all there is to know about the implementation of proximity search. We made it this far. Back to the presentation. Oops. Yes, back to the presentation. So I showed you the demo of everything. Although it looks simple, typing a query in, pressing enter, and showing the results, a lot happens behind the scenes. So hopefully you have an appreciation for new websites or other websites. So what I've learned, which is a pretty important slide. This slide is just a bunch of things that I've learned during my implementation of this pretty hefty user story. The first thing I've learned is that, and this is actually the most important thing, and this will help all programmers, is that it always pays to understand the code base. Let me repeat that. It always pays to understand the code base. Why is that? Because imagine you're a builder, correct? You're not going to just start building on any location. You want to build in the best possible location. You want to survey the property. You want to know what the issues are of the land. You want to know the best part of the land. And just imagine you're clearing a piece of land. You want to know where the issues are, and you want to know where the best part of the land is. It's the same thing with programming. You want to know everything about it so you know where to implement your property. It just pays to understand it. And that's the kind of programmer I am. The kind of programmer is I like to know, I like to give myself a huge overview so I won't be left in the dark when I have trouble in the code base, which happened a lot. When I had trouble in the code base, I knew exactly where to look, and that's a very powerful skill that you will take on your 6 to 7 sprints. So yeah, the next one is to try to find your place. I'd rather show an example rather than discuss that. So let's go to the back end. If you had a keen eye, you started noticing that, let's go to view. None of this is my code. This is a bunch of old code, and if I press Chris, all I did was change this one function right here. Alright, so here's a bunch of modules that I did myself. So here's search.py. All this is mine. This is my world. Here's google.py, which is the Google API. Hold on, I pressed caps lock by accident. This is the Google API stuff. All this is my code. And then here's location.py. All this is my code. Now why am I showing that? Why does it matter that I have my own modules? And let's go back right here. Try to find your place. The reason why I say this, to try to find your place, is because you're going to be stepping on other people's code. You're going to be stepping on landmines. You're going to be seeing, and not only are you going to be stepping on the previous people's code, you might be stepping on other people's code in the future when you start merging. So in order to protect against that, in order to hedge against that, you got to create your own place where you know no one's going to touch it. So with me, merging my backend was a breeze, just like BreazeHome. It was because no one touched google.py because no one had it. No one touched location.py because no one had it. So I had no conflicts. And I felt confident programming in this world. Let's see, search. I felt confident programming in this world because it's my world. I know that I didn't step on anyone's toes. I know that if anything goes wrong, it's only my fault. It's not anyone else's fault. It's my fault. And I know that if I successfully did it, it's all because of me. So this is the whole world right here, and it's documented really nicely, and I get to show off all my skills in one module. It's great, and this is a great idea to have, is to find your place. Now where do you find your place? I wish I had time to make a video of this, but I'll discuss it real quick. To find your place, you got to create like a perimeter where you need to find the smallest piece, the smallest connection to other people's code. And this, I'm just going to show this real quick. I really wish that I could make a video off finding your own place, but I just want to show you an example, and hopefully you could create the theory yourself. So if you notice, there's a lot of code. So right here, this is the start of my place right here, which is, this is where the front end connects to the back end. And then I just wanted this point right here to be where my code starts, and I wanted to avoid other people's areas. So this is where my perimeter starts. In a nutshell, I just wanted to have one point of entry, and I wanted it to not touch other people's code. I wish I could discuss it more, but that's as far as I'm going to do it. Find your place. Don't touch other people's code. Don't make other people angry. And you'll be everyone's friend. Always keep a backup. That's the next thing. So let me show you an example. In the beginning, you're going to have something called Breeze right here, which is perhaps the most stable code you're going to have. It's a gift. All right? Don't write into this at all. Don't modify it. Instead, create duplicates of it. Right here, like I have Breeze 2, Breeze 4, Breeze 5. Create duplicates of this, because what if one of these get corrupted, like 2, 4, 5? Then you have to redo the whole entire virtual environment. Keep the most stable code here and make copies of it. Just make copies of everything. And if you want to experiment, make copies, make copies, make copies. Have a copy you don't want to touch at all. The next thing is, don't be afraid to ask questions. I know we all want to keep the illusion that we're competent, but at the end of the day, a project of this magnitude, there's a lot of things that could go wrong. There's a lot of things you don't know. It pays to ask questions. Why? Because you get to solve your problem immediately. And I wish I learned this earlier. I always wanted to keep the illusion that I was competent, and I wasted a lot of time doing that. Please ask questions. I wasted a lot of time setting up my environment. My product owner was even kind of like, you're behind, because I wouldn't ask questions. I would like to do it myself. I wanted to show that I was competent. But at the end of the day, I just wasted time just to keep that illusion up. So please ask questions. Last but not least, and is actually the most important one, Git is your best friend in the darkest of times. I've had so many issues. Merge conflicts. I mean, nasty merges. Also, I've had, when I did implementation, I crashed the whole entire code base. I've had, one time I even forgot my implementation. What I'm trying to say is a lot of bad things could happen, and they will happen. And Git is used to save states of your code, and it pays to understand Git, because you get to save yourself from all the issues that will happen. You could always revert to a nicer state. Understand Git, understand the whole model of Git, have a very good understanding of Git. And plus, you're going to be using Git to merge into the master code base, which is, in a sense, your grade. So it pays to know Git. If you don't know Git, you're not going to get your final grade. I'm sorry, that's the way I got my grade, actually. Well, I mean, let me rephrase that. That's how I got to this point, because I actually merged to master, but it took a lot of understanding of Git, how to handle conflicts and all that. So from the first week, when you get those precious 2 weeks where you could learn whatever you want, the first thing should be there is Git. So yeah, let's go back to the presentation. In a nutshell, what I've learned: understand the code base, understand everything. No, don't leave any rock unturned. Keep an outline of the whole entire code base so you know where to implement and where to implement future stuff. Also, find your place, and the reason for this, you don't want to step on other people's code. Simple. Don't step on other people's feet. Always keep a backup. It's self-evident. When you have stable backups, you pretty much protect yourself from bad things in the future. Don't be afraid to ask questions. Every question you ask is time that you save. Please ask questions. Git is your best friend in the darkest of times. You're going to be using Git throughout the whole entire program. Alright? Learn Git in your first 2 weeks, please. If you have any questions, my name is Andrew Cristancho. My email is acris005@flu.edu. And thank you for watching if you made it this far. Thank you for watching. I had a great time implementing this user story. And a final piece of advice: when the product owner tells you to be a little more ambitious, take it. Because my search engine was going to be not even close to being like this. At all. And my product owner is like, be more ambitious, get that proximity search done. And I did it, and I didn't even know I could do it. I didn't believe in myself until he believed in me. So, believe in yourself. Thank you for watching.